Hello everybody, welcome to the Chapter 2 video project for stats class. In this video, a frequency distribution table organizing the data and 3 graphs displaying the data are to be constructed. First, let's look at the dataset that we're going to analyze. This is the raw data of the number of calories per serving for selected ready-to-eat cereals. We're going to create a frequency distribution table about this data, and a frequency distribution just means how the data are distributed. We're gonna put the data in 7 classes, which means 7 groups. In order to put them in groups, we need to find the class limits first. We see from the dataset that the lowest value is 80 and the highest is 270. We subtract these two numbers and divide them by 7 so that we get 27.1 for the width, but we always round one number up, so we get 28. But 29 is an odd number, so it's easier for us to find the midpoint of it. So we use 29 for the width of the class limits. So we get the first class limits from 80 to 80 plus 29, but minus 1 because we want the value between these two to be 29, so we get 108 here. And then, so the next class limit starts from 109, and then we get the 7 class limits. Although the values of the dataset are discrete, we still need the class boundaries to organize the data in a better way. So we find class boundaries by finding the lower boundary for 80, for example, and the upper boundary for 108, so that'll be 108.5, and then we do this all the way down. Then we get the class boundaries, and after that we are supposed to find the midpoints. Because we're going to use the class boundaries and midpoints in the following graphs, we're supposed to calculate them. The way to calculate the midpoint is to add the two numbers for the class limit up and then divide them by 2, therefore we get 94 for the first class, and by doing this we actually get all the numbers for the midpoints. Since we are doing the frequency distribution table, we are expected to find the frequency for each class, so we just count how many number of data are in one class. So for example 130, that'll be in this one, 190, this one, I guess. That we calculate the frequency is just count how many tallies we have. So this one is 7 and this one is 40. Therefore, we have the frequency for each class. The cumulative frequency just means how much you have for this class and the class previous to this class. So we basically just add up the numbers. So for the first one, we have 7. The second one, we add up 14 and 7, we get 21. And then we get all the numbers for the cumulative frequency. After all the data for the table are in, we need a title for the whole table. So the title might be maybe the number of calories per serving for selected ready-to-eat cereals. Therefore, we have the whole frequency distribution table organizing the dataset. We have class limits, class boundaries, and midpoints for the x-axis of the graphs. And we have tallies, frequency, and cumulative frequency for the y-axis. Therefore, we get all the data in. I'm not doing it in a very neat way because this part of the video is just showing the process. We have done a perfect, well, nearly perfect table before, so this will be the whole table about the data set.
So with the graph over here, we are now able to draw the ogive. First, we're drawing a coordinate. Start with 0, obviously. And I will simply put the interval on the left of 5 because it will be easy to graph it and find the points. And for the y-axis, we can pick class boundary, and ogive always start with 0. So I'll put 79.5, 108.5, 137.5, 166.5, and so on the bottom, on the x-axis. And it starts with 0, and the first data point is 7, 21, 23. And we just connect all the dots together. And the final graph will look like this. So we have the title up here, the number of calories per serving for celery for selected series, and cumulative frequency on the left, and number of calories on the bottom. Notice here, ogive always increasing because it is using the cumulative frequency. So you will never see a ogive falling or decreasing.
It is a J-shape ogive.
How to draw a histogram? First, you need a y-axis and the x-axis. Your y-axis is gonna be your frequency, and your x-axis will be your class boundary. Also, based on your frequency distribution table, mark the intervals on your axis. I will leave 2 cm for each interval. Write down the numbers. And do the same thing with your frequency. And based on the frequency distribution table, I learned that I have totally 7 frequencies needs to be marked. The largest is 14, so I'll leave 3, 6, 12, 15. And after this, start drawing the bars. For first class boundaries, I have frequency 7, so it will be here. Second class boundaries, I have a frequency 14, so that's gonna be. For third class boundaries, I have frequency 2. And for the fourth class boundaries, I have a frequency 9. And then do the same thing with all the rest of the frequencies. I'll show you a graph how a histogram is finished. You could choose to color your bars. just to make it look more clear. The shape of this graph is a little bit right-skewed.
And we're gonna start with the frequency polygon. And start with writing the title. The title should be then we're gonna have our y-axis, which is the vertical, and x-axis, which is horizontal, and x-axis should be our midpoints, and vertical axis should be the frequency. And after that, we're gonna label our frequency. We see the frequency is distributed from 2 to 14, then I'm gonna give and 0 at the bottom, so I will distribute it evenly so it's not misleading. And afterwards I have to label my x-axis too, and it's gonna be the midpoints. So we're gonna find the midpoints by using class limits. Class limits, let's give an example. For the first class limit is from 80 to 108. So the midpoints should be 108 plus 80 and divided by 2, which is equals to -4. I believe it's given in the distribution table. And it's a frequency polygon, so it starts on the x-axis and end on the axis too. So first the midpoint is 94, and we're gonna minus 29 from the first starting point, which is 65. And the ending point should be 268 plus 29 equals to 297. So this is a starting point and ending point. We give the starting point here, and then keep going, writing the distribute all the midpoints. And then we're gonna start from here. It's a starting point and it's gonna be 0. So when the midpoint is 94, the frequency should be 7. Should be around here, and this should be around here. And then we will connect them by a strict line. This is not very strict, but it will be with a ruler. Okay, I hope you'll see it's strict. So basically, that's the frequency polygon. And I was filming it doing it, so that won't be very perfect. And this is we did this previously, and this should be the perfect graph for it. And this graph is not exactly rescued, but a little bit rescued.
In the video, we did one frequency distribution table to organize the data, and then we constructed 3 graphs to display the data so that we can analyze them in a better way. For histogram and the frequency polygon, we can clearly see how the frequencies of the classes distribute, and for the ogive we can see the tendency of the frequency. Those 3 graphs are great ways for we to see the frequency and cumulative frequencies for the data. These are not limited ways that we can do this, but there are absolutely good ways that scientists and statisticians still use today. So thanks for watching the video and have a good day.